CosmoQuest's live coverage of the launch of the Parker Solar Probe. At this point, we are looking at roughly a 20-minute delay to our original launch time of 3:33 a.m. Eastern Time. We are now looking instead at probably launching in, 53 minutes from now instead. Now, NASA's coverage should be starting now.
From NASA's Kennedy Space Center in Florida, you're watching live coverage of the Parker Solar Probe mission to unlock mysteries of the sun's atmosphere. Good morning, I'm Marie Lewis. Thanks for waking up super early with us. We have team coverage of today's launch from a viewing area near the iconic Vehicle Assembly Building and from our reporters and commentators at the Mission Director Center. But first, Parker Solar Probe is targeted to launch at 3:53 this morning Eastern Time from Launch Complex 37 at Cape Canaveral Air Force Station. The launch window is 65 minutes long. Parker will take off on a United Launch Alliance Delta IV Heavy rocket, speeding up to 430,000 miles per hour in orbit. That's fast.
So please, you're not getting audio of this. Okay, let me see what I can do to get you some audio.
Close to our star without burning up.
There we go.
But first,
Sorry
we are
about
now
that.
about 51 minutes from launch. Let's check in with NASA's Josh Finch and Mick Waltman in Kennedy's Mission Director Center for an update on the count. Hi, guys.
Good morning, Marie. I'm Joshua Finch, and I'm joined today by Mick Waltman.
Good morning, Josh. I'm happy to be here today representing NASA's Launch Services program. Thank you.
Glad to have you with us. We started out this morning with a 65-minute window, but now we're sitting at about 45 minutes of our window. And Mick, can you tell us a little bit more about that?
Yes, Josh. United Launch Alliance and the NASA launch teams got on station about 6 hours ago. Teams have been working diligently through some minor issues that occurred with some ground support equipment prior to MST roll earlier this evening. And they got through that, and MST roll occurred. And then the team started working through the launch procedure. As they were doing that, they noticed some sensor data that they didn't really like, so they started looking at that, performed a little troubleshooting on the vehicle. They wanted to make sure all of that was working prior to going into the cryogenic load early this morning. So once they got that all done, they were ready to proceed forward. So that delayed cryo load just a little bit. With that, the cryo pole was taken to enter into the loading procedure, and NASA's launch manager Omar Baez and ULA's launch director Lou Mangieri coordinated a new T0 to help make up and get things processing back on a nominal timeline for 3:53 a.m. this morning.
And so we do still have 45 minutes remaining in our window should the launch teams need more time. You're looking at a live shot of the Delta IV Heavy rocket with the additional third stage at Space Launch Complex 37. The weather for today has actually been improving. We started out late yesterday with some storms in the area, but those have since cleared out, and our weather has actually improved throughout the count. Our winds are at 5 knots out of the west. Temperature right now is about 78, 79 degrees. The concerns that we were looking at earlier were cumulus clouds, detached anvil clouds, with a probability of violation of 10%. That's actually been reduced to now 5%. So that means we have 95% chance of favorable weather for launch. Again, you're looking at a live view of the Delta IV Heavy rocket, and behind is the mobile service tower that Mick was talking about that they rolled back earlier. Can you tell us a little bit about the MST roll?
Yes, MST roll went very smoothly. As I said earlier, they had a few issues with some ground support equipment that got started, but once they got that fixed and moved, the MST was jacked up and began rolling back as it moved back behind the Delta IV vehicle and exposing it to the sun. It was a beautiful view. The MST continued to roll about 400 feet to the north of the pad where it got into its park position for launch this evening. And once that was accomplished, the Delta IV vehicle was out there in plain sight for everybody, as we can see here this evening.
So I'm here to answer your questions and bring you other information as I can.
They're favorable, and us looking at the new T0 at 3:53, we'll go back to Marie.
All right, thanks, guys. Parker Solar Probe is named after Dr. Eugene Parker, a physicist who figured out 60 years ago that our star actually has its own wind and storms, and they can spread far into space. This space weather can disrupt communication signals from our satellites and even cause power outages. Besides impacts here on the ground, we also need to understand solar wind to help us better explore deeper into space. Just as ocean explorers need to understand currents, NASA needs to understand space weather to help us send astronauts to the moon, Mars, and other distant destinations.
Now, one thing to understand is this is the first time we've named a mission after a living scientist, and there's actually a bit of superstition, and let's face it, when it comes to things like launching spacecraft, everyone's lizard brain has opinions about things you shouldn't do unless you want to curse launch. Now, with spacecraft, the superstition is we should launch the vehicle, get back data, and only after all of those things have happened should we name it after a person. So the last mission became Fermi after it was successful. And this has generally been true with most big spacecraft. There are exceptions. Clearly, we've named the James Webb Space Telescope already. But there are those among us who are very concerned that because they named this after a tremendous scientist who's a friendly old guy who's still alive, here's to hoping that this launch completely proves all superstition, well, a non-scientific kind of thing.
And I realized that you just thought, million? That doesn't sound very close. Right. But you know, the Earth and the Sun are 93 million miles apart. And so if I put the Earth and the Sun in the end zones of a football field, Parker Solar Probe would tuck and run all the way to the Sun's 4-yard line, well in the red zone, knocking on the door for a touchdown, right by that goal line.
Well, that sounds extremely close to me. So I'm sure that folks are now wondering, how is a spacecraft not going to burn up at the 4-yard line?
We have a wonderful heat shield that we keep oriented between us and the sun. And so it keeps everything in the main body of the spacecraft nice and cool. It kind of creates a shadow. And it has a white coating on it that was specially designed for Parker Solar Probe, very much like you prefer to be in a white car on a hot day instead of a black car on a hot day. The heat shield is glowing and it is reflecting a lot of the sun's energy. And so the front side of the heat shield gets to about 2,500 degrees Fahrenheit, but everything on the main body in that shadow is at about 85 degrees Fahrenheit. So much like a pleasant Florida evening.
That sounds so lovely. Well, Nikki, thank you so much for being here today. We're all extremely excited about this mission, Go Parker Solar Probe. And with that, Marie, we'll go back to you.
So for a little bit of context, the folks that are covering this on NASA TV tonight, they're currently doing the what do we do if there's a lot of delays kind of amazingly well executed flex on video. This is one of those things that you don't have to deal with things like solar eclipses and many other kinds of scientific events. But when you're launching a vehicle, you never know what delays you might face. And so here we have them pulling out the interviews, pulling out the scientists. Anyone who isn't down in mission control for this spacecraft is probably somewhere on a set for NASA TV, helping to use this time that we have left before launch to educate you as much as possible. Now, I'm here from CosmoQuest, and we are a science education program, and the reason I'm doing this is so that I can answer all of your questions. There's no bad questions today, and in fact, every good question gives us something extra to talk about while we wait.
atmosphere. So as we're exploring the solar system, as we're going back to the moon, as we're heading toward sending astronauts towards Mars, we have to understand these solar energetic particles so that we can predict when the astronauts are going to get them and protect them.
Now, when you talk about prediction, are you talking about similar to the predictions we have for hurricanes that come toward the United States?
Yeah, so we're studying solar storms, and in order to be able to predict them, we need to understand some basic science about these solar storms so that we can make the models that do the prediction, just as meteorologists use atmospheric models that are very complicated in order to be able to predict the track and strength of hurricanes.
Okay, so I'm going to take over and answer your questions. So we have a question coming in from Quinn Culver first. If you could live on any star and survive healthily, what would it be? I think it would have to be Eta Carina. It's a pair of stars of which the largest is the one I'd want to be on. We think that there's a chance that this used to be a 3-star system and 2 of the stars combined into one, and those 2 stars are gearing up to go supernova, and it would be kind of cool to get to watch that process and ride the explosion. So Rosen Michael is asking, do you think that there's plant life on other planets? So specifying whether or not it's plant or simply non-intelligent life that grows based on light. I feel kind of weird saying the word plant because other worlds are likely to have forms of life that we wouldn't know how to classify other than alive but not sentient, so flora, and alive and is sentient, so fauna. Beyond that, we might not be able to describe things real well. So I do think there's probably life out there that lives off of starlight. So Dr. WD40, coffee. The answer is coffee. So looking to see if there's other questions. Good morning, Fenrig. So welcome everyone. It's a pleasure to see all of you joining us. Currently we are waiting for something cool to happen. And I'm answering all of your questions, so go ahead and ask away. What I'm really loving is we can see the various outgassing going on, and night launches have the potential to be truly amazing. I know there's been some issues with SpaceX just not having really great camera angles on their night launches, but this is NASA, and NASA knows how to choreograph a night launch, so I'm hopeful. So Rosen Michael's asking what got me into astronomy. I have the dorkiest answer ever. So, I mean, there are all sorts of various starting points. My parents made me take naps to stay up to watch the Voyager launches, and I could see the space shuttle coming in for a landing when it landed at Edwards Air Force Base when I was a little kid. But to be honest, I totally got into Battlestar Galactica, and when I realized that like a bunch of the names were based on Greek mythology, I started reading all about Greek mythology, and then I realized the constellations were named after the Greek mythological characters, and then I went from constellations to science and never really looked back. So I'm a long-time dork. Hey, Alan. Lauren Green was my endowment too. I do admit to having 2 Starbucks of equal love. So we are still... Thank you, Alan, for the gift to Dr. WD40. Let's light up that, let's light up the chat. Okay, so we have launch viewing info.
Thanks, Marie. Dr. Zurbuchen, You lead NASA's Science Mission Directorate. Tell us about the significance of this mission and what it means and why we need to study the sun up close.
This is one of our strategically important missions and the core mission in the heliophysics program, which is one of the 4 disciplines we're studying. It's so important because of 2 reasons. First of all, it's a basic astrophysics question, is how stars heat their atmospheres, their corona, and especially our star, the most important star in the whole universe, which is ours, how it does that. Just by itself, that's a really worthwhile question and it's worthy of studying. But it's also important because of space weather, namely that this star, that corona, is immersing us here at Earth and our astronauts and is part of the hazards of space, and we want to learn how to predict that because it affects our lives and our technological infrastructure, both in space and on the ground.
Absolutely. So I understand that this is the very first mission in which NASA named a spacecraft after a living person, Dr. Eugene Parker. And I also understand that you were the one who had the opportunity to make that phone call. So tell us what that means to you and why it was so important to name this mission after him.
So first of all, there's only one name that fits on that mission. It's the name of the pioneer that started it all. And frankly, I figured out with my team that there are 35 missions in our entire portfolio that studied the kind of things that Gene Parker predicted or studied during his scientific lifetime. And so he's just an incredible hero of our science community. And it was really exciting. You know, I knew Gene from being a young scientist and getting to know him, admiring him, and it was really cool to call him up and kind of surprise him a little bit. I remember it's like, first, it's like, I explained who I am. It's like, I met you. It's like, okay, look, would you be okay if we named a mission after you? It's like, I guess so. It's like, first person who ever have been asked that kind of question. So it's just really cool to call.
What an incredible opportunity.
Yeah.
So Dr. Parker is going to be here with us today. What are you thinking about the fact that you are about to watch this launch right alongside him?
I think it's just absolutely incredible. For me also, it's incredible for him and his family. I'm so glad his family is here too, but it's incredible for me just because it's a touching moment, right? It's one of those, life is all about these big arcs. And, sometimes you just see them, like how over a lifetime things come together and create these amazing stories, kind of these leaps going forward. I'm just so glad to be here with him.
Well, thank you for joining us. And Marie, with that, we'll go back to you.
All right, thanks, Tori. Discovering why the sun's outer atmosphere is so much hotter than its surface is a mystery that dates back almost 150.
Okay, so I'm going to talk over this poor woman who always ends up doing a lot of the filler content. So this mission will be studying coronal mass ejections as part of its program, and we're trying to figure out the details of where do they form, what causes them, what makes one be so much more violent than another, and vice versa. This mission will be long enough that we will get significant ability to watch the sun change over time. So Richard Hendricks is asking, would Parker be able to take Venus flyby pics? I believe that is something that it's planning to do. They do have a white light camera on board. Thank you, Bad Panda. And thank you, everyone, for lighting it up. That is a strange image. Okay, let's go ahead. This is getting amusing.
Light when heated. Light enters the spectroscope and is filtered through a tiny hole to isolate a single area. It then bounces off a special grating that disperses light into its different wavelengths. While sunlight contains every wavelength, scientists discovered that every chemical element and compound contains a unique pattern of wavelengths that allows scientists to determine the composition of light sources. It wasn't long before astronomers started extracting information from the light of distant stellar objects. In 1869, 2 scientists independently decided to point a spectroscope toward the corona during a total solar eclipse. As the sun's light disappeared, the pattern of wavelengths changed. They saw something they had never seen before. A bright green line that did not relate to any element found on Earth. For a short while, scientists named it coronium. It wasn't until 70 years later that a Swedish scientist discovered that these lines were the result of elements such as iron being stripped of its electrons. Every element has a specific number of electrons surrounding the nucleus. As each electron is removed, more energy is needed to remove the next one. The green line shows that iron has been stripped of 13 of its 26 electrons, indicating that the corona needed to be millions of degrees, counterintuitively far hotter than the sun's surface. Scientists have since proposed a variety of theories for what mechanisms could be adding that extra heat into the atmosphere. One theory suggests that small waves in the sun's surface pushes particles and heat into the atmosphere, a bit like how ocean waves push surfers. Another theory suggests small bomb-like explosions from the realignment of the sun's magnetic field create heat. Many scientists think it may be a mix of both. We've studied the corona from Earth during many eclipses, but to solve our star's biggest mystery, we have to make direct observations from the region itself.
We've had some stormy weather these last few days here at the Cape, but it's been pretty clear overnight so far. Let's check in with Josh and Mick in the Mission Director Center for a weather update. Guys?
Thank you, Marie. We are just a few moments out from receiving a weather briefing from the 45th Space Wing. Our launch weather office tonight will give us our final weather briefing for the launch countdown, which launch teams need to know. But when we're also a little bit out from entering a hold, and Mick, can you tell me a little bit about the hold?
Yeah, the T-4 hold that's coming up is the last opportunity for the team to take a look at the vehicle, all aspects of their sensors and data, everything that's going on with the Delta IV launch vehicle this evening to make sure they're ready to enter the count. And they've finished up their cryogenic loading, working on finishing that up, going into topping and maintaining of the first and second stage, getting ready to cycle vent valves and test out those areas of the first and second stage. So this hold will give them the chance to just kind of do one last look of the vehicle and verify that everything is ready and proceeding forward for a launch early this morning.
So while we wait for the hold, which we'll bring to you live, can you tell us a little bit about the U.S. Air Force and other things they do? So not only do they look at weather, they also look at what's called COLAs, or collision avoidance. And we heard earlier in the countdown that there are no COLAs for the T0 time or the launch window. But can you tell us why we look at that and about the COLA process?
Yeah, absolutely. The launch window tonight, as we mentioned, is 65 minutes. We've used up some of that already, so we have 45 minutes left in the window. And the U.S. Air Force performs a COLA, or collision avoidance analysis. One of the considerations they have to do in analyzing is for objects in space. For example, there might be other satellites that are around Earth that could be in the flight path of the Delta IV Heavy tonight once we launch. So as we look at this analysis, as you said, there are no cutouts or no COLAs for this evening in the launch window for the teams that they have to be aware of. So they'll continue to process forward with this 45-minute window. One of the interesting things about it is they actually start the COLA analysis several days before launch and then provide the last report up to the launch managers on launch day and get ready to help determine the T0 for today's launch.
And it sounds like we're just about to tie into this weather briefing.
Avila standing by.
This RCN Weather Conference Net 8, indicate ready to proceed. LD.
LD.
NLM.
NLM.
AFLD.
AFLD.
And we'll proceed.
This is Yellow. There's no clouds affecting our area and not expecting to have anything significant affect our area in the next 30 minutes. Looking at our constraints, we're going all constraints and not a concern for any space weather as well. Currently now we have just a 5% chance of violating launch constraints. This concludes the weather briefing unless there are any questions.
Indicate questions or acknowledge. LD.
LD.
NLM.
NLM, no questions.
AFLD.
AFLD.
This concludes the weather brief. Thank you, Evo.
Hello out.
And that was the weather briefing that you just heard, short and sweet, which means we have good weather for tonight. As you can see on your screen, the Delta IV Heavy there. No clouds that we're concerned with today. Earlier in the count, we were a little bit worse off, but we've gotten better, so no clouds to worry about. We're go on all constraints. That probability of violation, which is the POV number you see there, is 5%, meaning that we're 95% go. The winds are about 5 knots out of the west, and temperature sitting at about 78, 79 degrees, so no concerns for us tonight, which is a really good thing. And so that's the Delta 4 that you see on your screen there with the additional third stage. And we're now at T-minus 8 minutes, 20 seconds and counting. And for that, we'll go back to Marie Lewis for more information.
All right, thanks, Josh. Parker Solar Probe will set off to soak up.
Okay, so I've seen a bunch of questions in here, and I'm going to try and answer them while we go back to random conversations. So thank you so much, Alan One, for gifting Uncle Bill Droyne. So yes, thank you for answering that, Richard Hendricks. They will be able to observe the multiple flybys that they do of Venus. And I was trying to find more information on their website, but right now they have those parts of their website turned off, which I think may be a side effect of all the editing they're doing as they keep up with launch. So the other question that has come up is, what do astronauts do on the International Space Station? They do a lot of things that are absolutely not what you would expect. Their mission is one of building relations with other nations, of educating children in science with meetings via video conference from space down to Earth. They do a certain amount of science, running experiments on the space station, as well as swapping out various shelving units, essentially, for lack of a better term, drawers might be a better way of putting it, that are able to expose a variety of experiments to the vacuum of space. They raise animals and plants to see how the effects of zero-G affect them. And at the end of the day, they're also their own construction workers, constantly working to upgrade, change, keep functioning the International Space Station. So we're coming back.
Parker Solar Probe mission to kiss the sun and unlock its mysteries. Parker Solar Probe is targeted to launch at 3:53 this morning Eastern Time from Launch Complex 37 at Cape Canaveral Air Force Station in Florida. The launch window will be open for 65 minutes. Parker will take off on a United Launch Alliance Delta IV Heavy rocket, speeding up to 430,000 miles per hour in orbit. That's fast enough to get from Philadelphia to Washington, D.C. in 1 second. It will travel 7 times closer to the sun than any spacecraft before. Parker will help us understand how the sun affects weather in space. And why is that?
So I looked up an answer to the question we got earlier, comparing the Delta IV Heavy that they're launching on with the SpaceX Falcon Heavy that is currently basically being upgraded and perfected. So the Falcon Heavy is designed to launch 140,660 pounds of mass to low Earth orbit. Comparably, the Delta IV Heavy, which is the most powerful rocket that we currently have, can only take 62,540 pounds. So the Falcon Heavy has more than twice the launch capability of this Delta rocket. Thank you so much, Elite Ra, for the follow. Okay, so we are at the launch field.
Nikki, let's talk space weather. Help us understand Dr. Parker's theory of the solar wind.
So a lot of people get very excited about big space weather events when we have coronal mass ejections and flares and storms. But what a lot of people don't realize is that the sun is continually throwing off this solar wind. It is continually expanding and bathing all of the planets. So even if it isn't a really big storm, we can still see the impact of space weather here on Earth because the solar wind is continually buffeting our planet. When we see the very big events, however, that lets a lot of energy into the Earth's magnetosphere and down into our atmosphere, causing it to glow. We think of that as the very beautiful northern and southern lights. That's a current system in the sky, and that can cause problems for power grids here on Earth, problems for spacecraft out in orbit, problems for astronauts, problems for GPS accuracy, lots and lots of impacts for space weather, all driven by the solar wind as predicted by Gene Parker.
So there's a lot of great reasons we should be going on this mission and exploring the sun. Yes, and what about, this has been 60 years in the making, right? So how has this mission evolved since then?
So it's kind of an interesting thing because we've had to wait for our technology to really catch up with what we want to do. And yet it's because we have so much technology here on Earth now that we rely on every day, we're now even more susceptible to the sun than we were 60 years ago. If you think 60 years ago, if you wanted to make a phone call, you had a rotary dial phone that was attached to a wall, and now you hold it in the palm of your hand with more technology than you can even believe. And so we've needed that leap in technology to be able to enable us to do this incredible mission.
That is definitely incredible. And what about you personally? You've been on this mission for 8 years now?
Yes, 8 years. And so it's been a long road, but it seems like it's gone by like that. It's just wonderful to work with this team, and it's incredible to be standing here today looking at that Delta IV Heavy over there and waiting for it to take to the skies.
Or will you be watching the launch with Dr. Parker himself?
I will be. I'm privileged. I will be standing right behind him, or as close to him as I can be, and I can't wait to see the look on his face when that Delta IV Heavy clears the pad.
Wonderful. Well, I have to say one of the things I've admired most about throughout this mission has been your incredible wardrobe. So.
Oh, today's rocket.
Yes.
Yes.
Well, we're definitely looking forward to this incredible launch. And with that, Marie, we'll go back to you.
All right, thanks, Tori and Nikki. Let's go back to Franklin with more from heliophysicist Eric Christian. Franklin?
Thank you, Marie. Eric, during our first segment, we talked about the first question.
Okay, so I'm going to go ahead and answer the question about how this compares to Ulysses. Now, I have to first double check that I remember which mission the Ulysses was. I believe that it was polar orbiting. Yes. So the Ulysses probe in orbiting the sun had an extraordinarily different orbit from what the Parker Solar Probe is going to have. The Parker Solar Probe is on an orbit that's highly elliptical and is going to get smaller and smaller over time as it uses the gravity of Venus to change its orbit through multiple encounters. Now, one of the side effects of this is when Parker Solar Probe goes past the sun, it's going to essentially be going past it in the plane of our solar system, in this layer that all of the planets more or less orbit within. The Ulysses probe, because it wanted to observe the sun at all of its different latitudes going around from north to south, it was instead in an orbit that had an inclination of 80 degrees, and I'm trying to find a good diagram of its orbit that I can share. I'm just not finding one. There we go. So the Ulysses probe actually went all the way out to Jupiter to get the orbit that it needed. So it went much further out, so they had very different distances. And it was through these interactions that they were able to get it up to the inclination of 80 degrees that they wanted to get at. So it's not a true polar orbit. So polar would have been a 90-degree inclination, but it's pretty darn close. Looking to see what other questions. So Simsbad asks, what if the weather is bad? Is the launch delayed? So there's 3 factors that aren't spacecraft related that we really have to worry about as being consistent problem children. One of these problems is indeed the weather. There are issues of wind speeds, of visibility, but right now we're looking good on the weather front. As I saw come up in chat, we're at 95% favorable for launch. Now, other than just the weather, we also have to worry about things like fishing boats, stupid people in motorboats, other boat-like objects, ski-doos, those count. All these different things can have people that are in places they shouldn't be, who, because they're in jeopardy if something happens to the rocket, they won't launch the rocket to protect those people. Now, the final thing that we have to worry about is if there is a spacecraft that passes directly over launch. This means that while we're good to go at 53, we might not be good to go at 54, simply because of how things are moving so quickly. And, well, that means things can get in and out of your way both very quickly, and we have to follow that constantly. Now, this is kind of cool, so I'm going to clip into her.
Come in and touch the back with his hand. So let's get this started.
This is a piece of material identical to the heat shield.
Glowing red. The real heat shield gets up to about 2,500 degrees Fahrenheit, which we're not going to do today, but we are going to get it to a couple of 100 degrees Fahrenheit. So it's glowing pretty good now. Curtis, why don't you touch the back surface of that? What does it feel like? Nice and cool, he says. Which is just how we like it. Keeping the spacecraft cool.
We are now just minutes from liftoff. Let's go over to the Mission Director Center for a live update from United Launch Alliance, and then Josh will take us through the count. Josh?
Thank you very much. I'm now joined by Alyssa Macbeth from United Launch Alliance. Welcome to the program, Alyssa.
Thank you for having me. It's great to be here.
And Alyssa, can you tell me a little bit about ULA and what it's been like to work on this Parker Solar Probe mission?
Yeah, so it's so exciting to always get to work on an interplanetary mission. It's a great opportunity for ULA to launch a rocket that will put the satellite in orbit to Venus and eventually to the Sun. That's very exciting that we get to play a part in exploring the solar system.
And so I understand that you also brought a video with you that shows a little bit about the Delta IV after that T0 moment where it takes off through the flight. And show us the video?
Sure.
Sure.
2, 1, and liftoff. Liftoff of the United Launch Alliance Delta IV Heavy rocket.
3 Delta IV RS-68A main engines ignite and generate more than 2.1 million pounds of thrust to lift the rocket away from the pad. The Delta IV reaches Mach 1, the speed of sound, at 1 minute 18 seconds. At 3 minutes 56 seconds.
Just to repeat, this is half as powerful as the Falcon Heavy.
Are jettisoned. At 5 minutes 36 seconds, propellant levels deplete and the main engine shuts down. 7 seconds later, the Delta IV separation system activates to release the first stage. At 5 minutes 55 seconds, the first Delta cryogenic second stage, or DCSS main engine burn begins. At approximately 6 minutes 5 seconds, the payload fairing is jettisoned. At 10 minutes 37 seconds, cutoff of the DCSS engine, or MECO-1, occurs. At 22 minutes 25 seconds, the DCSS main engine is restarted for the second burn. Approximately 14 minutes later, second cutoff of the DCSS main engine occurs. Following a 30-second coast phase, the third stage is separated. 20 seconds later, the third stage is ignited. Approximately 1 minute 29 seconds later, burnout of the third stage solid rocket motor occurs. At 43 minutes 10 seconds, the third stage releases NASA's Parker Solar Probe spacecraft on its journey to the Sun.
So
United Launch Alliance is a consortium of a variety of different companies. As we move into this crazy new age of commercial space, we see NASA having as their backup plan a consortium of what may best be described as the old guard, Lockheed, Boeing, others, all working together to build NASA's new age of spacecraft missions. They're working currently on the Space Launch System that will be used to launch future Orion capsule missions that will hopefully be the other set of spacecraft beside the Dragon capsules on the Falcon missions that will be launching humans into space. It's unclear exactly when their first launch will be. They are looking at sometime late in 2019. Dragon is hoping for an April 2019 launch.
Are a team of engineers who have performed some final testing on the avionics systems, and at this point we are not working anything but getting ready for that final pull before we head into the terminal count.
So United Launch Alliance has facilities all over the U.S. Can you talk more about ULA as a whole and what they've put forward to design, build, and launch this Parker Solar Probe mission, and how do the teams company-wide work?
Yeah, definitely. So it takes a large group of people, exemplary people, to get where we are at this point. So we have design engineers who brilliantly produce and develop a rocket, and then the production sites in Alabama and Texas provide a perfect product to the launch site where we put it all together and do the final installations and hookups to prepare for launch. Teamwork is a standard at ULA. There's no doubt about it that we hold that to a high degree, and
we should now be roughly 10 minutes away from final countdown.
All the sites are working together and to get us to this point.
And for those of you that are just joining us, I'm sitting here with Alyssa Macbeth of United Launch Alliance.
So our most common question for the evening is, will they be able to take images of Venus as they fly by? They do have a white light camera, and they I believe this is part of their plan. I've been Googling for confirmation. The way they phrase it seems to indicate yes.
Launch as ULA since we formed in 2006. As you said, there are 3 stages with this specific payload, and the energy required is something that only our vehicle can do. It's the only rocket out there that can do what Parker Solar Probe needs it to do. So it's definitely significant in terms of performance of our rocket. We get to kind of show off here a little bit and show the world what ULA can do.
And again, on your screen, another shot of the United Launch Alliance Delta IV Heavy rocket at Space Launch Complex 37. Behind it, you see the mobile service tower, which is used to, it provides an access point for the rocket. Can you tell us a little bit more about what the mobile service tower does when it's around the rocket?
Yeah, so the mobile service tower provides 360-degree access. So any part of the rocket that you would need to get to in order to install avionics boxes, or get to the engines, or install ordnance, that mobile service tower provides that access to do that. And then at T0, that access goes away. So you can see you have the mobile service tower. Well, it's called the fixed umbilical tower there, and those arms will swing away as the rocket lifts off.
So we're at L minus 10 minutes, and counting on the L clock, the T clock is still stopped at the T minus 4-minute mark before we launch NASA's Parker Solar Probe. NASA's Parker Solar Probe will determine the structure and dynamics of the sun's coronal magnetic field. It'll understand how the solar corona and wind are heated and accelerated, and determine what mechanism accelerate and transport energetic particles. That was United Launch Alliance indicating how to indicate a hold in the count, although we're still marching toward a liftoff at 3:53 a.m. Eastern Time. We are inside of a T-minus 4-minute hold.
Verify the home fire switch is in the proceed position.
Ready to...
So the reason that they use these built-in holds is so they can put these checklists in, and they know how long the checklist should take. But this gives them some flex so that they don't have to constantly figure out how to add different things in. So these are generally pre-planned holds where they will start a countdown at some period beforehand. They'll recognize an issue. They'll go into a hold to fix the issue. They'll come out of the hold and count down to an expected period. Now, I'm looking up information on the orbit right now, and there are going to be a number of different encounters with Venus. And what's interesting is they're putting this mission into essentially an orbital resonance with Venus. It's going to go by 7 times. And each time as it's going by, it will linger near Venus for a different amount of time. Now, I'm also trying to look up all of the instrumentation so that I can find out more about specifically if they're going to be looking at Venus. So I'm not seeing it clearly. So all the different missions do holds. This is a standard part of how we plan these missions. So they're getting ready to pull away gangways, I believe is what they said. Here we go.
Poised for liftoff at 3:53 a.m.
So we're about 7 minutes away.
15 seconds before the poll.
Okay, so they're doing a poll for go. Soon, hopefully.
Status check to proceed with terminal count. First stage system, propulsion. Go. Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage systems, locks.
Go.
LH2.
Go.
Third stage systems, third stage vehicle manager. Go. Electrical systems, airborne.
Go.
Ground. Go. Facility. RFFTS.
Go.
Flight control.
Go.
COM.
Go.
GCQ.
Go.
Operations support.
No go pending the resolution of the Tisser anomaly just briefed on 6.
Roger. Pneumatics.
Go.
Umbilicals.
Go.
HAZGAS.
Go.
ACS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
Relay safety officer.
Go.
Vehicle system engineer.
No go VME status.
Roger. Anomaly chief.
No go VME status.
Roger. Range coordinator.
Clear to proceed.
Roger. LD, LC.
LD on 1.
Yeah, we have a no-go conditions going to not ready with your direction.
Roger.
LC switch not ready.
I don't know what VME is. I'm looking it up
AC,
right now.
please inform me of the not ready condition.
We will get you a report as soon as possible.
Roger.
And as you just heard, that was the poll done at the L-7 mark. And as you heard on the countdown, that we're right now in a no-go status. We'll stand by for more information.
This is the thing that these broadcasters actually hate, because what you say, they probably don't know what it means either. They may. It all depends on their familiarity with all of the different rockets, so we'll have all sorts of different errors. Yeah, I only know the Linux software use of it, Dave Killens. I'm having vehicle management something. Okay, that may give me more information to figure this out.
Okay, all personnel in Net 1. All console operators maintain system readiness. Allow the anomaly team to investigate the condition and be ready for a new T0 coordination.
So what I'm finding is this is related to test and launch control technology. Integrated Vehicle Health Management. It looks like it may be a kind of single board computer, and this is not something you want to have go bork. I'm trying to confirm that it's indeed this kind of hardware.
If you're just joining us, you see that the clocks are at L-4 minutes, T-4 minutes during the terminal count readiness poll that would allow us to exit the T-4 minute hold. We had a condition which the teams are looking into as we speak, and so we'll look to establish a new T0 at a time coming up. Mick and I will continue to monitor the situation here from the Mission Director Center, and we'll bring you more as we know.
Yeah, so these are single board computers. They're having an issue with a single board computer that is used for control. Yeah, so all of the work that they're doing trying to diagnose what the problem is being done remotely. They do have a number of communications cables. They may have actually switched to onboard communications at this point. Either way, whether it's onboard computers only or they're still connected into the ground, they have the ability to get lots of feedback out of the onboard computer. And hopefully they'll come back quickly and tell us if launches go or if it's scrubbed for the rest of the night. Because while I'm willing to stay up indefinitely to watch it go, if it is going to go, waiting 45 minutes. Hey, Commodore, thank you for joining. Waiting 45 minutes to watch it not go up due to a single board computer going bork in the night would make me a sad camper. So here is the situation for those just joining. They did the status call down the row, and there were numerous anomalies that were associated with a VME system. Based on me doing some Googling, it looks like the VMEs are single board computers that are provided for rockets. So I don't know more details than that. Yeah, Richard Hendricks, I don't know who they're buying from. I know that for the space shuttle they bought from Raytheon. I don't know who they've bought since then. Yeah, just don't know. So now we wait. So I think that we're working to no longer use Russian parts on anything Paranor. I'm not sure if we're there yet, but this is actually part of our goal. So we're already about half an hour into that launch window, Astro. So we haven't heard from Mr. Parker directly. We do know that he is on site, eagerly watching for this to hopefully for him and him alone. I want this to go right now, expletive, and go correctly. As I said earlier in this stream, there is that
We're here in the Mission Director Center monitoring as launch teams continue to work toward a liftoff time. Mick, can you tell me what the launch teams are working on?
Yeah, the teams right now are, in the T-4 holding. You heard the poll for the no-go situation that they're doing, and so the teams are taking this chance while the assessment is being done to evaluate what's going on. The other parts of the team are taking a look at the rocket and just verifying that all other aspects of the vehicle are still within specifications, and ready to proceed forward with the T0 tonight. So as the EGSE team takes a look at what's going on, they'll get back to the launch director and launch conductor to let them know their resolution, and we'll look forward for a new T0 as we continue to hold here at T-4, using up some of the window that's still available. Right now we have 39 minutes left in the launch availability window for this evening's launch.
So you're looking at a live shot of the Delta IV Heavy with the additional third stage on your screen there. Mick and I will continue to monitor the count, and we'll bring you updates as we know it.
I love Paranor's comment there about how the fellow on the right looked like a worried, expecting father. That's very much the situation that these folks are in. One of the unfortunate truths that all scientists who rely on spacecraft are forced to deal with is you can spend 10 to 30 years of your life building one spacecraft as the entire thing that you do. And then if it blows up on launch, the next decade or so that you were planning to spend working on that spacecraft and then spending whatever was left of your life processing its data, well, you've now lost all your funding. You've lost your electronic child of science. And there's a chance you might not have a job the next day. And that's really hard. In some ways, it is as desperate as giving birth. I mean, imagine that you've been working your entire graduate school career on it, and your instrument is finally flying, and there's no money to rebuild it, and it blows up. You may not get your PhD. It's hard. So Paranor is asking, Richard is asking, have there been any spacecraft named after women? Sort of. I hate that the answer is sort of. The Herschel space probe was named after both William and Carolyn Herschel, two siblings that did amazing work mapping out the locations of faint fuzzy objects in the sky, whether they be galaxies or nebula, and their efforts formed the foundations of the NGC catalog, which stands for New General Catalog. Now, we haven't really had any sense, so it's the way it is. It is totally harrowing to spend all your time on something and then give it to someone else. And this is part of the frustration with James Webb Space Telescope. Its construction was begun, I believe, in the 90s. And they hired people straight out of master's degrees who were engineers to work on that mission. These people are now in their 40s, and their spacecraft still hasn't launched. And this is the only thing they've done with their career. Yeah, it's hard. So I don't quite know what to say. As someone who had a Japanese X-ray satellite that I needed for my dissertation, failed to ever return science data, I deal with this by working on archival data most of the time. I did break my personal promise to myself to not rely on spacecraft ever again by being part of the Bennu mission, where we're creating software to help them find the rock.
You are looking at a live shot of the Delta IV Heavy rocket at Space Launch Complex 37 on Cape Canaveral Air Force Station. On the bottom of the right of your screen, you see the T clock, which is stopped at the T-4 minute mark. Mick, can you tell us a little bit about the clocks?
Yeah, the T clock is used by the team to continue working through the launch procedure. We also
Okay. I'm going to work on explaining to you a little bit about the problem with James Webb not launching. While I'm deeply amused with Fraser saying we should just never launch it so it never fails, the problem is that there's no worse place for a spacecraft than on the ground. On the ground, these things that are designed for zero-G are holding themselves up. They have the potential to collect dust. There's the potential that humidity will leak into a system. And beyond that, with James Webb, as it continues to need more and more work, it's continuing to use more and more of NASA's budget. NASA has a very small budget in the grand scheme of things, less than $6 billion any given year. And with the small budget that it has, when you start comparing it to so many other things out there, just the amount of money that Americans spend on laptop computers every year, when you start looking at NASA's budget and realizing that there are going to be budgetary effects from plans to develop a space force, there are going to be budgetary effects from all the other things going on where changes are being asked for and new things are being desired, somewhere NASA's going to have to find the money to keep working on James Webb, which should have launched, whose budget should have gone on to building future new spacecraft. All these new things take money away from other projects. And right now, people like me are scared and worried and wondering, what is our future? And we know that launching James Webb is a greater financial priority than supporting me and my team. I fully acknowledge that. There's no question. I still don't want to wake up one day to that email that says, "We're sorry to inform you, but..." I went through that with sequestration. I can go through it again. But it's hard. It's hard. So, yeah, we actually added a new rule to the CosmoQuest list of rules today, and that is one does not discuss Space Force or James Webb Space Telescope. It's too soon. So we wait, just like we're now waiting for this launch as the minutes tick away as the window works towards closing. Yeah, sequestration was hard on a lot of us. So this is where we fill time. What gets me though is looking at this shot, you see flashes going off all around on the ground. And I'm wondering what the ground level ones are. And part of me wonders, are those camera flashes? I just don't know. Do I want to Google what that is, DPI 209? I have no idea what that is. Yeah, it could be warning lights, but those are usually much higher up on top of the buildings and the launch towers. Oh. Okay, I see what that is. It's probably not going to happen. So I don't watch Fraser all the time. He and I have a very different philosophy on spacecraft. They are dead to me completely until they have a launch date. And they are mostly dead to me until either I'm prepping for a launch like this evening, or they're actually launched and returning data. So, yeah, we just need to see what ends up happening. I fully understand their philosophy, Richard. I fully understand their philosophy. So what other science questions do you all have as we sit here watching NASA's feed go silent as no one quite knows what to do in response to anomalies putting them on hold. This is probably one of those moments where all of the scientists I am listening to them. You're not.
The mission will provide unprecedentedly close
they're
observations
not saying what the mission is. There's no new information. They came on and said there's no new information, and we're waiting to hear. They're now doing the standard boilerplate on what the mission is. So I have no idea what the bright red flames burning near the pad are. Those are deeply concerning, but I'm assuming that it's some sort of a normal fuel burn-off. So Larry, Tess is alive when it returns exoplanets and someone confirms it's working up to spec. It found a comet. We're going to go with that. Okay, so while we wait, someone had a question a minute ago. I was about to answer. Let me scroll back. And now it's gone. Now it's gone. I don't know what I was about to say. I didn't know that, Dave. I don't know what all they vent and don't. I know they often vent and burn methane around here. Yeah, I'm just not sure. Oh, the question was, why are things orange? The orange is actually the natural color of the materials that the rockets are built out of. And I don't know why they paint some parts of them. Just don't. But in general, the reason they stopped painting the space shuttle external tank and why they don't paint all the parts of these tanks is because paint adds weight. Any of you who've ever tried to carry around paint while you're fixing up your house know those puppies add up. You're actually adding weight to your house, adding mass to your house every time you paint it. And all of that adds up. And these rockets are huge, and all of that weight adds up. And if they don't paint it, they can launch a bigger spacecraft. So it's to protect it from weight that they'd rather put into a spacecraft. Let's avoid the explosive word. That's cool, Uncle Bill. Thank you, H4RLI. Harley, I think that's Harley. Thank you, Harley, for the follow. It's amazing to get to watch these launch, Hanny. And the first time I saw a Delta launch, I don't think it was a Delta 4 Heavy. I think it was a Delta 2. I could be wrong. It was for the Grail launch. And they're slow to get off the launch pad. So the entire cloud of exhaust engulfs the spacecraft, and then it emerges out of that cloud of exhaust. And when you don't know that's exactly what's about to happen, I did have a wee moment of thinking that everything had gone horribly wrong. But that's not going to be the kind of issue we worry about right now. For those of you joining us late, They had an anomaly that they reported as a VME anomaly. Based on some Googling, I believe that VME is a kind of single board computer. These were used on the space shuttle where they came from Radcon. I incorrectly said Raytheon earlier this evening. 2 letter R words I didn't read far enough. So now we're waiting to find out if they're going to be able to fix this anomaly prior to the close of tonight's launch window. They do have to launch in the correct direction, that the rotation of the Earth and the angle of their launch will head them off to correctly have all the flybys they need. Now, if the Earth is pointed in the opposite direction, or more to the point, Florida, where they're launching from Cape Canaveral, is pointed in the wrong direction in its planetary rotation, we're just not going to have an orbit that gets us where we're trying to go. So we have a limited launch window.
Hit. Roger. LD net 1. LD. NLM net 1.
NLM.
Proceed, AC.
Okay, this occurred about a minute after the expected response from the ground PSM stream. This is from the vehicle. The team has evaluated the data. We recognize that it was from the vehicle. The streams are good, and we are in a good position to proceed. The risk level is the same as what we had discussed previously and voted to proceed. So the anomaly team is recommending we try again.
Okay.
LC concurs. LD. LD concurs. NLM.
NLM concurs.
And you're looking at a live shot of the Delta IV Heavy at Space Launch Complex 37. If you're just joining us, we are at T-4 and holding. We started tonight with a 65-minute window. We now are down to 23 minutes. But Mick, can you tell us a little bit about what we just heard on Countdown 1?
Yeah, absolutely. The team evaluated the vehicle from the no-go situation they had in the T-4 poll a little earlier. What they were working on was a ground data stream that comes from the launch vehicle back to the computers in the control center. And the team looked at that data hit that they had gotten and have determined that they completely understand it, and the data stream has returned
LC,
to its
this
normal
is LD on
operation.
channel 1.
And
Go
the level
LC,
of comfort
please
is
coordinate a new
good,
T0,
and they are ready to
08,
proceed forward as they reported to the launch conductor.
Roger. 08:28:000. RC. LC.
RCN1.
Please coordinate a new T0 0828.
Roger and work.
ALC, please set the clock for 0828. Roger. OBM LC net 1.
Go LC.
New target T0 082800.
Copy. Target 082800. We'll proceed into checklist A.
Roger.
LC clock has been set for new T0 of 0828. We're at approximately L60.
Roger.
I think they just said that they're going to be launching in 15 minutes. I'm waiting for someone at NASA to confirm that I did that right.
And from Delta Launch Control, I'm Josh, and I'm joined with Mick Woltman from NASA's Launch Service Program, and we just heard a countdown from the launch teams. Can you characterize
LC,
what that
RC,
update was?
net 1.
Yes, Josh.
Yeah,
What the team was doing is, we were talking a little earlier, the team evaluated the ground data stream from the launch vehicle. They've determined they are good to proceed with launch this evening. So NASA's launch manager, Omar Baez, and United Launch Alliance's launch director, Lou Mangiuri, have coordinated a new T0 time this morning for 4:28 a.m. That's approximately 16 minutes from now to get Parker Solar Probe on its way towards the sun. So we're hoping for a smooth liftoff this evening as the teams continue to work forward and through the count procedure and get ready to pick up the count coming out of the T-4 hold.
And so we'll pick up that count in just over 10 minutes.
I believe that is correct.
Okay, so I'm sitting here typing in an answer to the question. I can now just go ahead and answer it. So the scientists do have somewhat of a say. Now, they don't get to override anyone. No one gets to override anyone. But they do get to say there's something wrong with the spacecraft and argue it out with the engineers. Now, I don't know the exact story of Alan Stern preventing a launch.
Well, it's 14 minutes.
Okay, we're at 14 minutes. I completely believe that as being a possibly true story. But there are compromises. It's not like you end up with scientists shouting with people down in mission control. Everyone is quite reasoned, and they have conditions for go and no-go.
Go, Avia.
Third stage recycle checklist A is complete. We're on external power.
Roger.
Okay, so now they're going through and unplugging things. So they've switched power to be using the spacecraft's systems instead of relying on essentially a plug into the launch station. And I'm now Googling the story. Can't find it easily, but it looks like it may be part of their new story, their new book about New Horizons.
From Delta Launch Control, you're looking at a live view of the Delta IV Heavy rocket with the additional third stage at Space Launch Complex 37 on Cape Canaveral Air Force Station. I'm Josh, and I'm joined by Mick Woltman of NASA's Launch Services Program. We've coordinated a new T0 for 4:28 a.m., which will leave about 10 minutes left in our window. And Mick, can you tell me, now that we've reset the clock to about L-12 minutes, what we can expect?
Yeah, as we move forward from here, the launch teams will continue to work through their procedure, stepping through all aspects of the Delta IV launch vehicle. And as they get ready to enter into the terminal count, what we will see is the launch teams prepping the FTS system and getting it armed and ready to go. We'll see the third stage enter onto internal power as they perform their testing and get ready for launch. And then the Delta launch vehicle, second stage and first stage, will also enter onto internal power and getting ready for those final few minutes prior to liftoff this morning. And then about just prior to liftoff, we'll have the RS-68 engines being purged with a hydrogen purge that's going through there, and that will fill up around the engines and create some pockets around the Delta IV Heavy launch vehicle. Once the RS-68 engine ignites, it'll actually look like the Delta IV Heavy is engulfed in flames a little bit, but that's actually normal for a Delta IV Heavy launch vehicle because of that hydrogen purge that started prior to launch, and that all catches in the ignition of the RS-68. So the team will be very busy in those last 4 minutes prepping for the count and moving forward towards a liftoff at 4:28 this morning.
And can you tell us a little bit more about the Delta IV Heavy that we're looking at on our screen?
Yeah, absolutely. As we talked a little earlier, this particular Delta IV Heavy for Parker Solar Probe has 3 common booster cores, each with an RS-68 engine, which is a hydrogen-fueled engine that provides the thrust to get out of Earth's atmosphere. Sitting on top of the center core is a Delta cryogenic second stage, which is powered by an RL-10B engine, which will provide that intermediate escape velocity for the Parker Solar Probe mission once it's in space. Moving up the stack, you have the 5-meter fairing, which is encompassing Parker Solar Probe, and the mission unique third stage that was provided by Northrop Grumman Innovation Systems, a Star 48 BV motor. It's a vectorable motor that once in space, the Star 48 will provide that last little push for Parker Solar Probe to get into its trajectory heading towards the sun. Another unique thing, and we keep talking about this being a historic mission today, Josh. It is a very historic mission of getting Parker Solar Probe onto the sun, as this has been thought about for the last 60 years to get out and study the sun. But for some of our viewing audience, Launch Complex 37 is also a historic launch pad. back in 1960s, it was used as part of the Apollo program, launching Saturn 1s and Saturn 1Bs. It was also the place where we launched the first unmanned lunar module from. And then ULA acquired Launch Complex 37 in 2001 and began their program of Delta IV launches from here. So it's a historic launch all the way around for United Launch Alliance and NASA this evening.
And so for tonight, it'll launch NASA's Parker Solar Probe, which will make repeated journeys into the sun's corona and trace the flow of energy to answer fundamental questions such as why the solar atmosphere is dramatically hotter than the sun's surface, what accelerates the solar wind that blows outward through the solar system, and what is the source of this high-energy solar particles. Parker Solar Probe will make 24 elliptical orbits of the sun and even use 7 Venus flybys to shrink the orbit closer to the sun during the 7-year mission. The probe will fly 7 times closer to the sun than any spacecraft before, a mere 3.9 million miles above the surface, which is about 4% of the distance from the sun to the Earth.
So I just confirmed by reading through some of the technical papers on the spacecraft that the imager on board the spacecraft will be able to image not just Venus, but will also be looking at Mercury and other sun-grazing comets and inner asteroids. So we are 1 minute away from the status check for launch at this point. So in addition to being able to image all those fabulous objects, they're also going to be using the imager to look for dust, patterns in the dust out in the area inside these 2 different planets' orbits. And there's other instruments on board as well that will be looking to study the particle environment and look for other colors of energy that may be detectable. So here we're looking at the colors that aren't necessarily visible to your eyeballs. Yeah, what Richard Hendricks is saying about playing Kerbal Space is entirely true. I admit I've only played it a couple of times. I need to move past that. Yeah, you can learn a whole lot
Status
about
check
physics.
to proceed with terminal count. First stage systems, propulsion.
Go.
Hydraulics.
Go.
Locks.
Go.
LH2.
Go.
Second stage systems, locks.
Go.
LH2.
Go.
Third stage systems, third stage vehicle manager.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Com. Com.
Com is go.
GCQ.
Go.
Operations support.
Go.
Pneumatics.
Go.
Umbilicals.
Go.
HAZGAS.
Go.
ACS.
Go.
Red light monitor. Go. Quality.
Go.
Op safety manager.
Go.
ELA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. MEQ established, swing arm lock pins pulled.
Active.
So what I was in the process of typing up
From
is
Delta
they
Launch
used to
Control, you just
wear,
heard the terminal count readiness poll with permission.
They used to wear Hawaiian shirts in the mission team control room. Those were all of the blue polos that you saw out at Johns Hopkins APL. Unfortunately, the Hawaiian shirt tradition got wrecked during the Rosetta encounter by someone whose shirt was not mission authorized. So now we see everyone is happily wearing blue polos. So we still haven't started counting, but we should be starting any second now. So I'm sure the mission team ate the peanuts and we just didn't get to see the peanuts. That's also another tradition, is everyone eats a peanut. So as I said earlier, there is the superstition against naming things before they're launched imperfect. And here they've named it after a living person, so please don't have any flaws, because he's a nice old guy. Even if he was like a moderate but not crummy old guy who was a brilliant scientist. It should launch. And Larry, I agree, terminal count is a really bad phrase. We have many of them. There we go. Okay, everyone. So I'm going to switch this over to the big screen. And I'm going to move the text. One moment, please.
We are at T minus 3 minutes, 35 seconds and counting. Coming up at the 2.5 minute mark before launch, the launch conductor will ask the NASA spacecraft coordinator to verify that the spacecraft is on internal power.
Minus 325.
About 15 seconds later, NASA launch manager Omar Baez will give Lou Mangieri of United Launch Alliance, he's the launch director, the NASA go or no-go for launch. About 1 minute before liftoff, the launch conductor will ask the range operations coordinator, or ROC. You'll hear the status for ROC to report range. At T-minus 0, the United Launch Alliance Delta IV Heavy will lift off from Space Launch Complex 37. The Delta IV Heavy begins flying on its planned trajectory, and just under 45 minutes later, NASA's Parker Solar Probe will separate from the third stage, beginning its mission to study the sun.
Does anyone else think that looks like a Lego rocket?
You've just heard the call for the flight termination system to go internal. From now, we'll be listening to the launch teams live from the Delta Operations Center.
Flight pressure and flight level.
As we enter in the final minutes of the countdown, we'll listen in to the...
NSC verifies spacecraft on internal power.
We'll listen to the launch teams count down into the final minutes of the count. And the NASA's Parker Solar Probe is verified to be on internal power. After launch, we'll hear the voice of United Launch Alliance.
Elite
Patrick
Ra,
Moore,
don't
giving
curse
real
us.
live telemetry of the Delta IV performance.
T-minus 2 minutes.
Hydraulic press at 4,000.
Vehicle internal.
Poof.
Hold. This is RLM. And what LC is not ready. All personnel, go to race cycle pages, operation 90.
The LC is a GH helium regulator inlet press.
Oh, they're having a problem. They hold it at 155.
T-minus 1 minute 55 seconds.
I hate everything.
From Delta Launch Control, we are holding at the T-minus 1 minute 55
I'm
second
seeing
mark
on
in the count.
Twitter that they're resetting to -4.
We have 9 minutes and 15 seconds remaining in tonight's window.
Good Lord. I feel like we should place bets on whether it should launch. Okay. So I'm watching Twitter, and I will bring you what I see there, since NASA TV does appear to be
Flight
behind.
control, you ready to reset the clock T4 and holding?
Flight control is ready for that.
Roger. ALC, reset the countdown clock T-minus 4 minutes and holding.
Roger.
PLE, evaluate LOX recycle and report if ready to restart LOX pumps.
Roger.
LC, pumps are running.
I see everyone on Twitter saying, oh, it's not launching tonight.
Roger.
LC countdown clock has been reset.
Looking for confirmation.
Roger. OSM, place SRM ignition switch at disabled position.
SRM is at disabled.
Oh man. Scrub, I'm now seeing it from multiple people.
OBM, perform third stage recycle checklist.
It's moving too fast to read.
LC, are we going again tonight?
We're past T-minus 2 minutes negative.
So we have 9 minutes left in
Copy
tonight's
that.
window.
At this point, we'll proceed to our power down checklist.
Yep, they're powering down. It's scrubbed.
LC net 1.
Okay. I will be back
LD
here
on 1.
tomorrow.
All right, LD, with our scrub past L minus, or excuse me, our hold past T minus 2 minutes, you need to recycle back to L minus 4 minutes. Window will not support that second attempt.
That is correct, so let's set up for 24-hour recycle.
Roger.
Okay, well, I'm gonna pull up tomorrow's weather. Okay, so tomorrow's not looking good. Let me bring the weather in for you to see. Sorry for the ungracefulness of that. So we're looking at rain tomorrow. Not so here's the 2 a.m. to 5 a.m. at Cape Canaveral. This is basically when they're looking at launch. So I don't know what to say, folks. These are the disappointments that we go through when we love our space and we want to send things into it. Go dream well wherever you are in the world, or should you choose to stay awake, make those dreams come true. I'll see you all on the other side, and hopefully there will be a fabulous spacecraft waiting to take us to the nearest star tomorrow night. So this has been our live coverage of Parker Solar Probe and its scrubbed launch. There will be a new window for takeoff tomorrow. I don't know the exact time yet. I will share it out as soon as I can. Thank you for watching. This is brought to you by CosmoQuest.org. We invite you to help us. Please go map out other worlds. Help us mark the craters and find the scientifically interesting places to explore. We have a particular data call for Mars and Mercury right now. Thank you so much for all the follows tonight. And I think we may have just made a serious dent in the world's coffee supply. So stock back up. And if we look like we're go for launch, I will be go to stream. Bye-bye, everyone.